The following question reads that which element does not form a stable ion with the same electronic structure as argon? Now, starting with the first one, we know that aluminium's electronic configuration has 13 electrons, so it's 2, 8, and 3. Now, if it's 2, 8, and 3, the aluminium ion that is formed is usually, it's always plus 3. It's in group 3, it's going to be plus 3. So it loses its 3 outermost outer shell electrons. Now, if it loses 3 outer shell electrons, you're only left with 2 electrons and 8 electrons. That's a total of 10 electrons. Now, the question was that it is forming a stable ion. The question was which element does not form a stable ion with the same electronic structure as argon. Now, remember, we have to compare it with argon. Argon had 18 electrons, so argon's electronic configuration is going to be 18 would be 2, 8, and then another 8 electrons in the third shell. So, as you can see, aluminium ions have 2 electrons in the first shell, 8 in the second shell, and 0 electrons in the third shell. Argon's electronic structure is 2 in the first, 8 in the second, and 8 in the third. So aluminium is forming a stable ion, but it is not forming a stable ion that has the same electronic structure as argon. While if you look at the rest of the atoms, chlorine is 17 electrons, 287. So that chlorine is in group 7. It usually forms a -1 ion. If it forms a -1 ion, instead of 7 electrons, they're going to be 8 electrons in its outermost shell, which is going to be exactly the same as argon. Similarly, phosphorus has 15 electrons. Its electronic structure is 2, 8, and 5. But phosphorus forms a -3 ion. It's in group 5. So instead of having 5 electrons, it's going to have 8 electrons, 3 extra electrons in its outer shell. So its electronic structure is going to be similar to argon as well. And the same would be true for potassium. Potassium has 19 electrons, so its electronic structure is going to be 2, 8, 8, and then 1. But potassium forms, it's in group 1, it forms a +1 ion, it loses its 1 electron. So it's also left with 2, 8, and 8 electrons in its third shell, which is going to be the same as argon. So option A is going to be the correct answer because its stable ion is not going to be exactly like argon.